Imagine a creature so small it could fit in your palm. Now, imagine that same creature possessing a dental system so revolutionary, so impossibly advanced, that it would take mammals another 100 million years to catch up. What if I told you that while dinosaurs thundered across Jurassic Portugal, a mouse-sized mammal was quietly perfecting a tooth replacement strategy that would make a great white shark jealous? Here's what's coming. First, you'll discover why this creature's teeth were more sophisticated than a T-Rex's. Second, you'll learn how a fossil smaller than your thumb changed everything we thought we knew about mammalian evolution. And third, the most shocking part, why this tiny Portuguese pioneer might be the reason you're sitting here today with the teeth you have. What scientists just discovered about Cambelodon torreensis will change everything you thought you knew about who the real evolutionary winners were. This is the story of the thumb-sized revolutionary that outsmarted the dinosaurs with nothing but its teeth. Picture this. It's 150 million years ago in what will become Torres Vedras, Portugal. Massive sauropods lumber past, their footsteps shaking the earth. Pterosaurs shriek overhead. And there, hiding in the leaf litter, scurrying between the roots of ancient conifers, is a creature that weighs less than a modern hamster. Cambelodon torreensis, just 8 centimeters long. That's smaller than your smartphone. It looked like a cross between a shrew and a vole, with tiny black eyes, whiskers that twitched constantly, and fur that helped it blend into the shadows. You might think something this small would be irrelevant, just dinosaur food waiting to happen. But here's where it gets crazy. This minuscule mammal possessed something that would have made a saber-toothed cat envious. A dental system so complex, so precisely engineered that modern paleontologists needed electron microscopes just to understand how it worked. To put this in perspective, imagine your teeth could self-sharpen like a beaver's, regenerate like a shark's, and maintain the precise grinding surfaces of a horse's molars all at the same time. That's what we're talking about. But here's where it gets even crazier. Unlike every mammal you know today, including you, Cambelodon could replace its teeth throughout its entire life, not just once like we do with baby teeth, not randomly like reptiles, but in a controlled, systematic way that maintained perfect occlusion, that's the way teeth fit together, throughout its entire existence. Scientists have measured these fossil teeth down to fractions of millimeters. The largest molar, 1.8 millimeters. That's smaller than a grain of rice. Yet each tooth shows wear patterns indicating a lifespan of constant, heavy use. These weren't just teeth, they were precision instruments. Here's a fact that surprises even paleontology professors. Cambelodon belongs to a group called multituberculates, mammals that survived longer than any other mammalian order in history. 130 million years. That's twice as long as the entire age of dinosaurs. And it all started with creatures like our tiny Portuguese friend. Let's talk about those impossible teeth. Modern mammals, including you, follow a simple rule. 2 sets of teeth, that's it. Baby teeth, adult teeth, done. It's called diphyodonty, and scientists thought it was the price we paid for having complex, precisely fitting teeth. Cambelodon said, "Hold my prehistoric beer." Through CT scanning of specimens found in the Guimarães coal mine, researchers discovered something that shouldn't exist. This creature had developed a conveyor belt system of tooth replacement that maintained perfect grinding surfaces while continuously refreshing its dental arsenal. To put this in perspective, imagine if your molars could sense when they were wearing down and automatically signal a replacement to start growing, but only when needed and only in perfect alignment with your other teeth. That's engineering that we can't even replicate with modern dentistry. But wait, it gets more impressive. The bite force? Now, you might think something hamster-sized would have a pathetic bite. Wrong. Relative to its size, Cambelodon could generate pressures that would put a modern rat to shame. Those tiny jaws could crack open seeds and nuts that its dinosaur contemporaries couldn't even notice. Scientists used to think early mammals were just insect eaters, scurrying in the shadows. But new evidence shows Cambelodon's teeth were specialized for something much more ambitious: omnivory. Those multi-tuberculated teeth, covered in tiny cusps like miniature mountain ranges, could slice, dice, grind, and pulverize everything from tough plant material to insect exoskeletons to small vertebrates. Here's where our tiny hero gets terrifying, at least if you're an insect. Scientists used to think creatures this small were purely prey animals, spending their lives in constant terror. But new evidence from the Torreensis fossils shows something unexpected. Cambelodon was a nighttime hunter. Picture this hunting scenario. It's midnight in Jurassic Portugal. While the giant predators sleep, Cambelodon emerges. Those constantly replacing teeth aren't just for defense, they're weapons. Using echolocation, yes, some multi-tuberculates had this ability. It tracks down a beetle the size of your thumb. The attack is swift. Those self-sharpening incisors punch through the beetle's armor like can openers. The multi-tuberculated molars go to work, grinding the prey into digestible paste in seconds. The entire hunt takes less than a minute. But that's not even the most surprising part. Fossilized burrow systems found near Cambelodon remains suggest something revolutionary. These creatures may have lived in colonies, not just family groups, actual colonies with dozens of individuals. If true, this would predate eusocial mammalian behavior by over 100 million years. Here's where our tiny hero gets terrifying, at least if you're an insect. Scientists used to think creatures this small were purely prey animals, spending their lives in constant terror. But new evidence from the Torreensis fossils shows something unexpected. Cambelodon was a nighttime hunter. Picture this hunting scenario. It's midnight in Jurassic Portugal. While the giant predators sleep, Cambelodon emerges. Those constantly replacing teeth aren't just for defense, they're weapons. Using echolocation, yes, some multi-tuberculates had this ability. It tracks down a beetle the size of your thumb. The attack is swift. Those self-sharpening incisors punch through the beetle's armor like can openers. The multi-tuberculated molars go to work, grinding the prey into digestible paste in seconds. The entire hunt takes less than a minute. But that's not even the most surprising part. Fossilized burrow systems found near Cambelodon remains suggest something revolutionary. These creatures may have lived in colonies, not just family groups, actual colonies with dozens of individuals. If true, this would predate eusocial mammalian behavior by over 100 million years. Scientists used to think complex social behavior was a recent mammalian innovation, but new evidence shows these Jurassic pioneers might have been sharing food, raising young communally, and even posting sentries while others foraged. Now, you might wonder, in a world of giants, how did something this small matter? Let me blow your mind. Cambelodon and its relatives were more successful than most dinosaurs. While T-Rex existed for about 2 million years, multi-tuberculodons like Cambelodon dominated terrestrial ecosystems for 130 million years. In a fight between Cambelodon and a Compsognathus, one of the smallest dinosaurs at just 1 kilogram, you'd bet on the dinosaur, right? Wrong move. While Compsognathus needed to find prey during daylight, competing with dozens of other predators, Cambelodon owned the night. While Compsognathus laid eggs that were vulnerable for weeks, Cambelodon gave birth to live young that could run within hours. But here's the real kicker.
Cambelodon wasn't competing with dinosaurs. It was competing with other mammals. And this is where those revolutionary teeth made all the difference. Fossil evidence from Portugal shows at least 6 different mammal species living in the same area. The ones with simple teeth, they specialized in single food sources. When that food disappeared, so did they. But Cambelodon, those ever-renewing, multi-purpose teeth meant it could switch from seeds to insects to fruit to small vertebrates as needed. It's like bringing a Swiss Army knife to a fight where everyone else brought butter knives. But here's what keeps paleontologists awake at night. How? How did a mammal develop continuous tooth replacement when every other mammalian lineage gave it up? It's like finding a modern car that runs on coal. Technically possible, but why? Dr. Thomas Martin from the University of Bonn, who studied the original specimens, discovered something that shouldn't exist: evidence of stem cells in 150-million-year-old teeth. These weren't just teeth that happened to regrow. This was a controlled, genetically programmed system more advanced than anything in modern mammals. Even more puzzling, why did this ability disappear? If continuously replacing teeth is such an advantage, why don't you have it? Why doesn't any living mammal have it? Recent discoveries suggest something disturbing. We might have had it and lost it. Genetic studies on modern mammals show ghost genes, deactivated DNA sequences that could theoretically produce continuous tooth replacement. It's like we all have the blueprints for this superpower, but someone deleted the instruction manual. But that's not even the most terrifying part. What if I told you that Cambelodon's tooth replacement system wasn't unique to them? What if it was the default for early mammals, and we're the weird ones? New fossil evidence from China, North America, and Morocco shows that multiple early mammal lineages had some form of continuous tooth replacement. But here's the shocking part. They all lost it around the same time, about 60 million years ago. If this creature existed today, it would revolutionize everything. No more dentists, no more dentures, no more worrying about cavities. Just fresh, perfect teeth whenever you need them. But wait, it gets stranger. Computer models suggest that if multi-tuberculates like Cambelodon hadn't gone extinct, they would have prevented the rise of rodents. No rats, no mice, no squirrels. Instead, we'd have hyper-intelligent, colony-dwelling, continuously toothed mammals filling those niches. Cities wouldn't have rat problems. They'd have Cambelodon problems. And trust me, you'd rather have the rats. Imagine trying to pest-proof your home against creatures that can chew through literally anything and never run out of teeth. So why does a hamster-sized creature from Jurassic Portugal matter to our understanding of life on Earth? Because Cambelodon torreensis proves that mammals didn't survive the age of dinosaurs by hiding and hoping. They survived by out-engineering them. While dinosaurs got bigger, mammals got better. This connects to modern conservation in a frightening way. Today's smallest mammals, shrews, rodents, bats, they're not evolutionary afterthoughts. They're the descendants of winners. When climate change ended the dinosaurs, creatures like Cambelodon didn't just survive, they thrived. The lesson? Size isn't survival. Adaptability is. And nothing says adaptability like teeth that never stop improving themselves. This discovery links to other extinct creatures in mind-blowing ways. Remember Repenomamus, the badger-sized mammal that ate baby dinosaurs? It had similar dental adaptations. Velaticatherium, the Jurassic gliding mammal? Same tooth type. There was an entire shadow ecosystem of advanced mammals that we're only now discovering. Want to know something that'll really bake your noodle? The extinction of multi-tuberculates like Cambelodon might be why humans evolved. With these dental dynamos out of the picture, primitive primates could access food sources that were previously monopolized. No Cambelodon extinction, no you.
Let's rapid fire through what we've learned. A creature smaller than your phone had teeth more advanced than yours. It could replace its teeth forever while maintaining perfect bite alignment. It survived 130 million years, 65 times longer than our entire genus. Its extinction might be the only reason primates and you exist. We have the dormant genes for this ability locked in our DNA. The philosophical reflection hits hard. We think of ourselves as evolution's pinnacle, but we lost abilities that a Jurassic mouse thing perfected. Progress isn't always a straight line up. Here's my question for the comments. Could humans have survived alongside multituberculates like Cambelodon? Or would these perfectly adapted, continuously armed micropredators have prevented our evolution entirely? Let me know what you think below.